two things we have to remember. We have to remember quadratic function, like what the form the quadratic function is right here. And then we have to remember something called the standard form. I think we've done some of this a little bit already. This is called the standard form. Sometimes people call this the vertex form. And the reason they call it the vertex form is because when we write it like this, it has, I don't know, you guys can't see the pointer because I'm already pointing. So you go to, you can get the vertex right here when you write it in this form. So sometimes standard form is called vertex form. Alrighty, do we remember that? So the first thing that they're going to do is just like example 1 here. So we're going to go forward to the assignment and look at, well, a couple of questions here. So how about number 1? That's a concept question. This is on the assignment. We could go right in order if you prefer. But it says to put the quadratic function right here in standard form, we complete the what? Complete the, we're going to be looking at one of these in a second. It's your favorite thing in the world to do. Complete the square. Yes, sir. Yeah. Well, it's just square. Complete the, oh, on your assignment sheet. Yeah. 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 Complete the square. Another one that we are looking at is quadratic function, f of x equals, right, this. That's in standard form, also known as vertex form. So what would the vertex of this parabola be? Yeah, hk, good. So if a, this value here, is greater than 0, that means that my parabola opens up or down. Yeah, it's going to open up. And in the case where f of x equals k is the blank value of a function, max or min. Well, if it's positive, it opens up like this. So we're going to have a minimum, right? So minimum value of f. So what questions do we have on 1 or 2? We're good on those? You betcha. Okay, so number 4, here we go. We have an actual quadratic function right here. It's a parabola. Is it going to open up or down? Yeah, it's got a negative. So down, we know that. The vertex is going to be at, is it -2 or +2? Yeah, it's going to be at +2 and -6. So that's common, but this is x minus h. So to get a -2, we have x minus a -2 is where the -2 is coming from, or would have been coming from, but this is a plus. So it's 2, -6. And f of 2, let's see, what would that be? Yeah, at 2, x is, or y, oops, I got my erase on, would have to be -6. And it is it opens down, so it must be a max. All right. So we did a conceptual one over here with 2, and then an actual one right here with number 4. Good there? All right, let's do one ourselves. This next section has to do with completing the square. So they want us to express f in standard form, find the vertex. Well, once it's in standard form, that's pretty easy. And then we can find the intercepts, sketch the graph, find the domain and range. So let's look at, what's the very first one? Number 10, I guess. So x squared plus 4x minus 1. I'm going to come over here to where I can do, can you see this? X squared. Scooch it a little bit more. X squared plus 4x minus 1, was it? So I want to complete the square on this. So remember, our trick is to say x squared plus 4x plus something minus 1. So I want to complete this square right here. So to do this, I have to take half of the 4 and double it or square it? Yeah, square it. But you get the same number, so, but you do square it. So half of 4 is 2. We double it and we get, I'm sorry, I just said what you said. We square it and we get 4. But can I just write plus 4, or do I have to balance it off with a Yeah, I got to put a minus 4 there. So plus 4 and minus 4, that adds up to 0. So now I can say, all right, this is a perfect square. It's x plus 2, quantity squared, and I can add those things together to get a minus 5. So part A done. Have it written in vertex form. Then it's asked for what? What is the vertex? It's in standard form. So the vertex would be also known as, yeah, -2, -5. So with the k, right, h and k, h you're kind of taking the opposite, k you're keeping the same. Yeah, Morgan. Because if we're doing this, well, k, I'll write my k there. So if I'm doing standard form here, I have to get a positive 2, to get a positive 2, I have to have a negative here. So plus a negative makes this a x plus 2. So that's where the -2 is coming from. So good question there. Alrighty, what else are we looking for? Are we looking for intercepts? X and y intercepts. So to get the x-intercept, make the y a 0. So let's see. I'll label this x-intercept. So I'm solving for, this also is a little bit easier to solve for when it's written in this form, because I can do what? We can see that okay? Yeah, I want to isolate the x term, so the first thing I have to do is get this 5 moved out of the way. Then I want to do what? Will be Christmassy. Take the square root of both sides, right? So when I take the square root of a number squared, we get the number. And that's going to give you plus or minus. That's where the plus or minus is coming from in the quadratic formula. And then we do what? Yeah, subtract the 2. So those are the x intercepts. This is harder to figure out. So what can I do? Can I use a calculator? If I want decimal approximations. Somebody with a yellow box of magic handy. Can we do that? -2 plus, I think square root of 5 is about 2.136. So this is point, because the two right here is negative. So 0.236 and -2 minus 2.236. All right, so here's one of them when y equals 0, and there's the other one. So we got our two x-intercepts. How do we get a y-intercept? That is correct. So when you want x-intercept, you put a 0 in for y. When you want a y-intercept, we put a 0 in for x. So simplify this, and we get, let's see, 0 plus 2 is 0. 0 squared is 4. 4 minus 5 is -1. Everybody in the back see that okay? So that tells me that the point 0, -1 is a y-intercept. So it's only crossing the y-axis once. Will any of these ever cross the y-axis more than once? If they're concave up or down? No, they will only ever cross it once. But over here, we're going to have two solutions for the x-intercepts. All right, what was the other? There were a couple other things we looked for. I'm looking in my physical book here. Sketch a graph. Oh, and find the domain and range. All right. Oh, sketching a graph. Let's see. Can I sketch a graph? Suppose I can do a graph, right? And I know that 0, 1, no, 0, -1. 0, -1. 0, -1, that was the y-intercept. And let's see, 0.236 would be, oops, I have erase on. 0.236, That's out here. And the other x-intercept was negative 4.236. So 1, 2, 3, 4, 5. And that would put me where? Right about here. And what was our vertex? Let's see, negative 2, 5. So negative 2, I count over 2. And then I got to go down 1, 2, 3, 4, 5. So round about here. Raise your hand if this is fun. Yellow box of magic, way better, right? But yeah, you can graph this on a calculator, double check it. But based on all the analytics we did, all the algebra we did over here in this section, we were able to come up with a graph. And then now that we've come up with a graph, can we get the domain? The domain is all polynomials or all real numbers. Do you have to use interval notation, or can you write all real numbers? You can write all real numbers if you want to. So it's a matter of personal preference, I think. So you could write all reals. Domain, let's see, that starts down at negative 5. I should make this look more like a parenthesis. And goes to infinity and beyond. Or could you say all real numbers greater than or equal to negative 5? Yeah. The range, let me switch colors here. The range starts down here at negative 5. The range is what it does going this way, up and down.
Yeah, I know that, but I don't know how I got negative 1 to my range.
Well, negative 1 is this value right here, I think, the function value. So we got that as a y-intercept. But when we graph the function, the range goes from down here all the way to positive infinity. So that's where we could say all reals greater than or equal to negative 5. So remember, domain is you're just going this way, the domain. Range is up and down. It's a little bit, it's kind of important. It's a little bit easier to get the range if you see a graph. But the easiest way to graph these is how? Graphing calculator, right? And look at the graphing calculator, because the graphing calculator will find the minimum for us. Okay. Good there. So what questions?